So, welcome back everybody. Tim Golden is here with NetworkZero, support for clubs, classes and dojos with us. So please welcome Tim.
Okay, so a couple of years ago, with the club I helped to run in West London, we entered the Pi Wars competition in Cambridge. It was great fun. You build a robot, you enter into a competition, that's our robot up there. And we decided, of course, we had to remote control the robot, it's part of the rules. And so we decided we use sort of a controller and connect to the laptop by Wi-Fi and so on. And to do that, we had to faff around a fair bit with setting the robot up as a Wi-Fi hotspot and then finding it and all that kind of business as well. But it did work. Although one of the troubles was that when I was developing the code to talk to for the controller, to talk to the robot and so on my laptop, on the train, on the way to work, I obviously had to faff around with the IP addresses, the ports we were using and how we were going to find it and so forth. And then when I came to the club in the evening, we had to change the light round again because of the different address and all that kind of business. So then, a bit later, within the last year or so, we decided to do a different project which involved a turning sort of turntable with a Pi controlling a motor and a couple of flaps, and you could fire Nerf darts to these flaps and gain points, and I did it deliberately as a sort of a three-part, three different Raspberry Pis, so we could have three different teams working on them, talking to each other across the network. So you fire the Nerf dart, and you can see there from our sort of Blue Peter-ish concoction. It closes a circuit, creates a, raises the GPIO pin, and that then sends information to another Raspberry Pi, which counts your score, and the whole thing is controlled by a third Raspberry Pi, which starts and stops the turntable. Okay, a little bit artificial actually, but you need to have at least two, otherwise the wires get kind of mired up. And to do that, I sort of reused some of the network code I'd written for the robot, and we had a sort of similar problem, except we had three Pis, and we never remembered which was which doing which, and so we had this sort of network mayhem going on with everything trying to connect to everything else. Oh, that's my IP address, we have to change your code now, so it's 192.168.0.24, and then, oh, well, that's what I had last time, and then you've got to change that code, and so it was all a little bit about, okay. So I then thought to myself, okay, so is there some way, there are other people in the same situation. This is a Raspberry Pi at Teddington, or code a dojo at Teddington, in a school there, which I help out at regularly. And the typical thing, actually we're not using NetworkZero here, but when you are using networks in a jam or a dojo or in a classroom situation, one of the challenges you have is trying to get the things to connect to each other, knowing what they're called, what's the IP address, do they the same port and so forth. And the other challenge is actually getting them to send messages to and fro, because network is not that easy. So, there are two sides to the module I put together for this package, NetworkZero. One side is what's called discovery. So, advertising and discovering services, for want of a better word, on the machine you're on. So you don't have to work out the IP address every time, or a port number for that matter. You just advertise, I'm running the robot service here, and then that can be picked up or discovered by other machines on the same network. And the other side of it is very simple messaging. Send a message, receive a message, send a reply, and a sort of simple pub/sub, receive news, send news sort of thing. And so that's what I put together to be of use to myself and other people in schools and clubs. And at the same time, I was keen that this be able to be used across platform, across Python versions, so it needs to be able to run on Windows, Mac, Linux, and particularly Raspberry Pi, but also across the different versions of Python, 2.7 and at least 3.3 upwards. I think I may run on 3.2, I'm not sure, but 3.3 is the only thing we tested against. So that you can get, because with all of this, I was conscious that teachers or club leaders or dojo mentors or whatever need to have the least possible fuss when they're trying to go and do something with code. You don't want to have to try and work out, is this going to work, is this going to install, have I got the live version of Python, oh, I've got a Mac, is that going to work, and so on. So this is behind what I've tried to do to make this work. There's some buts on the end of this sentence towards the end of the talk, okay? But nonetheless, this is the intention behind it. So I want the thing to work in a robust way across as many platforms and versions as you reasonably could expect. Fine. So neither of these things, the discovery of services or the sending of messages across the network, is a particularly new problem. There are some reasonable solutions itself. I didn't mention, but I'm actually using ZeroMQ for the socket work here. And you can use native sockets, you can write a socket server or use the built-in Python socket server or some other solution like that, depending on how much pain you're prepared to go with, because obviously the more this pain grows as you go cross-platform, particularly with sockets. But I'm focusing a little bit here on the particular constraints of a tight time frame, or 1 hour workshop or whatever it might be, and relatively inexperienced to young coders. This is a robotics workshop we ran at my club last term to try and get us the EduKit 3 robot they're putting together. Again, they haven't yet got to the point of using the NetworkZero in this session, but that's what we'll be using for that. And there are difficulties enough trying to do this with young and inexperienced coders, and so I'm trying to work within that set of constraints. So I created NetworkZero. And there's the read docs page. I don't expect to read it now. If you want to, you can go and find it on the web. And now, the idea behind NetworkZero is in the same school as various other zeros you may have come across. There's Daniel Pope on the left, the creator of PyGameZero, the more or less first of the zero-style libraries. Ben Nuttall in the middle, who created GPIO0, and Laura with GUI0, and all of them here if you haven't met them already on the education track or elsewhere in the conference. And I think there are other zeros around there that I don't happen to have come across. There's a Bluetooth one, I think. The idea of the zero suffix is to make Python packages which are built on powerful libraries, on things that already exist within Python itself, within the standard library or elsewhere, but make them an easier entry point for beginners. So typically try to avoid a certain amount of fairly noisy boilerplate that has to be there for the thing to work, but that just sort of confuses young and perhaps slow typists as they sort of put in a load of stuff that doesn't really quite do very much until they actually get to the byte when it actually starts doing things for them. And cutters up what will otherwise be simple code. So in each of these different cases, the authors have sort of moved out of the way, out into the background, some things which you'd have to do for yourself, but at the same time, they're layered on top of libraries which you can drop down to. So PyGameZero is obviously based on Pygame, and you can sort of drop down to that if you need the power beyond what the Zero version gives you. GPIO0 built onto a number of backends, originally the standard RPI GPIO module, and GUI0 is based on the tkinter toolset that's built into Python itself. And so likewise, NetworkZero sits on top of, primarily at the moment, ZeroMQ and one other module I'll talk about. So, how do you use it? Okay, well, in its simplest form, I don't know if that's actually readable, but at least you can get some idea. This is from the docs page. So on the top there is computer 1, and you simply import NetworkZero, and I always alias it as NW0 just for simplicity, but obviously you can import it how you like. You advertise an address that you're going to be using, the address of a service, and I see the echo address is NW0 advertise some name, and then you wait for a message, and from that on that service and send a reply to it. So it's quite simple. I'm here using, for those who know ZeroMQ, I'm using rec socket types here for simplicity. I had a discussion with someone last year. I suggested using another type, but I sort of went somewhere with it and backed away from it for the moment. The rec has the advantage that it's quite simple. The semantics are quite simple. You send a request, you receive a reply. You have to receive a reply. There's a little bit of fuzziness in here. I've built in to let you sort of automatically send a reply. But basically, send a message, receive a reply. It's easy to at least think about. And the other machine on the network, or it could be just another process on the same machine, in fact, discovers that service of the same name, and then sends a message and prints a reply, sends a different message, prints a reply. This one obviously is saying, hello, name I gave to you in the first place. Okay, so to give it a simple example. And that's it, really. I mean, in the sense that that's what NetworkZero does. You've seen most of its functionality there, not all. And so the sort of idea is that you can either build a program, and again, this is not aimed at professional developers who are looking to build their entire commercial system on this, clearly not. This is aimed at giving young people the ability to write code which will work, which is essentially network-based in the first instance. For example, it is a little chat room or something like that, or it's sort of using, I can't think of the example at the moment, sorry, I've gone blank, or to add some network glitter to an existing bit of work. So you've written some kind of hangman game or something of that kind, or sort of robot turning thing, and you can build in some network ability so that somebody can control that robot, or you can play the hangman from a different machine with a minimum fuss. So that's the idea behind it. and the picture of people there that are not actually excited about NetworkZero, I'm afraid to say. This was from one of the PYCON UKs a couple of years ago, and the pictures by Nicholas Ptolemy. But at least that's what I hope kids will look like when they're fascinated and awed by NetworkZero. I realised I've run much faster than I thought I was going to there, so okay. Let's get on to a live demo. Nothing like live demos. Okay, so has anybody actually tried installing this? If not, I'll run this myself. But has anybody tried to do it? Can you? So if you can, if you're connected to my Wi-Fi, if you can see it, the West Park Club Wi-Fi, you know, to reconnect off the city one.
What's the password?
Just an email. Sorry. Whoops. It's try Toadstool with a small t, 0 sorry, 0 Toadstool with zeros instead of O's. Sorry about that, I didn't think of that. So T, small O, sorry, small t, 0, AD, ST, 00L. That might be the password, it might not, we're about to find out. It's sort of hard-coded into my thing somewhere. So what should happen is, I've got a Pi here running the blink strip that for those of you here before Josh was demonstrating his EduBlocks. And if you send it, if you can discover it, and then send it a message with a tuple that's your name, or anybody's name, whatever, and an 8-character string of RGB or W or blank, then it should light up the lights on there. And it should also come out of presentation mode on PowerPoint then. Okay, and it should also come on, don't do this to me. Oh, it's decided not to do anything, that's good. Oh, lovely.
We're meant to be sending a message to.
Send a message to. I mean, I can't bring it up, can I?
You managed to connect to the Wi-Fi?
Did anybody get on the Wi-Fi? If not, I'll just do this from here. So,
Yeah.
okay, so sorry, I'm afraid my machine's not going to try and force the.
There we go.
Well, I knew my light demo was flaky, but I don't think it was going to be flaky because of the screen not showing. Okay, let's come back to the. So that's what you're trying to do. Okay, once you connect to the Wi-Fi, import the NetworkZero as whatever. Discover the Blink service, which I'm running on the Pi. Send a message to it using the address that came from Blink, and then a name and RGB tuple. And if it's working, then I should see, the light should obviously go, and I should see something on the news, which I'll show you in a moment. Has anybody tried it yet? Because I'm not seeing any lights. Okay. Okay, someone's going, fine.
Yeah, me.
And it looks like Steve sent RGB, W, RGB, W. Thank you, Steve, whoever you are. And I'll just set that up a little more visible. I don't know, may not be. I'll just send one myself, so I'm going to send as Blink as tip2, and I'm going to go for RRRR, VVVV. Okay, see? Come on. Interesting, the advert's expired. Right. Okay, so this is good actually, because it gets me the opportunity to talk about the things that don't work. Because, okay, at least we got one work. Thank you very much for that. So, part of the problem here is that networking stuff is hard. So, there are a number of difficulties that I discovered as I was putting this whole thing together. And my PowerPoint decided not to go in there. It's a good day for me. So, a number of difficulties occurred. But first of all, I'll talk about the good things first, okay? What works when it works. So, the good thing here is that what you have is two simple services, discovery and messaging, which complement each other but don't have to be used together. So the point here is that the discovery simply returns a string, which is in fact an IP address port pair. and you pass it into the other things, but if for some reason the discovery is based on a UDP beacon, if for some reason that doesn't cross your network or something else happens, you can simply say it out loud if you need to. You can simply print it out and say it. Or you can just ignore it. You can not discover your, you can ask your friend, what's your IP address? So the discovery doesn't, the messaging doesn't need the discovery, and the messaging will work on its own as well. Or if it's handy for you to do discovery, then do some other transport, then that's also fine. So as far as it goes, its strengths are that it does what it says on the tin. It does work cross-platform. It's fairly robust, but as you can see here, there are always problems of one sort or another. It works on Python 2.7 and 3.3 upwards. You can send and receive any built-in type. Actually, Marshall's using JSON at the moment, which means if you want to send bytes, you have to do a little bit of encoding. There's a couple of built-in functions to do that. So you can, in fact, send and receive images across it, but you have to do a bit of encoding, basic to encode, essentially, at the moment. I did originally send and receive with Marshall, but that causes problems when you're sending between different versions of Python. For those who don't know, Marshall is Python's built-in marshalling code, which it uses itself to create its bytecode files, but there's no guarantee that it won't change between versions, and it badly does. So if you need to send between versions, and you do, because I'm running Python 3.4 on the Raspberry Pi and Python 3.5 on the laptop here, then you need to use something else. I chose JSON because it's fairly widely used. It is designed to be fairly robust in the face of odd network setups. I'll talk about the hard dependencies in a moment, but it does use the NetIFaces library to try and overcome some of the differences between networks. It's actually thread safe. So originally it wasn't going to be, because it was going to be a sort of simple thing saying, well, okay, you can use it anywhere. Who's going to be using threads if they're using something as simple as this? But then Ben Nuttall and the chaps in the GPIO0 library pointed out that they use threads for their callbacks. And so if you want to do something networky on a callback, on a GPIO callback, somebody presses a button and you send a network thing out, it has to be thread safe for that to happen. So it actually is thread safe, you use thread locals and so forth. It's got two fairly simple mechanisms, request reply and publish subscribe, and they do what it says on the tin, so it doesn't get very complicated. Okay, what are the weaknesses? Well, you've seen one of them just now. It is, I actually haven't looked to see what particularly failed there, but it is, despite its best effort, it is prone, or it's sort of susceptible to network latencies. Network itself is hard, and you can sort of layer stuff on top that makes it easier. 0MQ makes it easier, hopefully this makes it easier, but there are often, and perhaps always, difficulties. This library tries to overcome some of those by using, in this case, for example, 0MQ, which is sort of has a bit of buffering and a bit of smoothing out in place, but ultimately things still go wrong, and that's not easy in a classroom or dojo situation. It also tries to recover from errors, or it tries to warn you loudly when you're not going to be able to recover from errors because if a socket drops, etc. But nonetheless, things like that do go wrong, and that's no amount of library work can overcome that in every situation. Another difficulty is that it has two hard dependencies at the moment: 0MQ and NetIFaces. NetIFaces is a simpler one. It's a small library that simply somebody put together to allow you, for example, to determine the gateway, default interface, and so forth. Because my laptop here has 3 or 4 different network interfaces on it, some physical, some virtual. Raspberry Pi has at least 2, and depending on what you're doing, also you have localhost on each one of those. And it tries to cope with that situation. 0MQ is advertising itself as sockets on steroids, and so I put it in place. I used it because I used it before, in fact, to overcome some of those cross-platform difficulties. So I did have difficulties as it was with when I created the discovery beacon, which is its own UDP beacon. But having hard dependencies means installation is trickier. And I had some difficulties even here, and I know what I'm doing with it, trying to get the right versions of everything together to make it work. In a classroom that could be, in a school that could be tricky still, and I recognise that. On the one hand, it would be nice to get rid of the dependencies, so that you can just pip install directly. On the other hand, the whole point about using these libraries is that they're doing the work you would otherwise have to do yourself. So if you don't use 0MQ, then you're basically going to re-implement it badly, as they say. NetIFaces, works across all the platforms and works out, does the various sort of incantations which are different for every platform, look at the source code, and you basically have to do that yourself or compromise and use a less successful solution. Find something that will kind of work most of the time but won't work some of the time, and then you've got a teacher because they put us odd VLAN on the Ethernet network for the Raspberry Pi, so the WLAN is different. and then you're into difficulty. So that's one of the drawbacks, but it's also a benefit. And there are corner cases you see here where it still doesn't quite do the business. So, I'll just tell you one or two of the things that were a little bit unexpected when I was developing it. Just that, that are things you might not have suspected anyway. One thing is actually the naming. I'm not 100% sure even now that the names of the API are quite right. So I've gone in and out with the function naming on the messaging. Is it send message to? Is it send message via? All this kind of thing. I obsessed about it for a while. I stopped obsessing after a while and just get on with it. But it is a difficulty. One thing that caught me out, at one point, if you pass a host name in as a service name, not a service name, but you pass a host name in when you're sending a message, it will try to resolve it to work out if it's actually a host name or a service name. Now, I was expecting it to simply not resolve. If it was not a valid host name on the network, it would simply not resolve. If any of you have used BT, and I guess other people do this as well, BT automatically resolves unknown host names to some landing page of its own, where it says, hey, did you want Gardens R Us or Tools or whatever? Which is great. So I've actually got a specific trap in there for that specific IP address, whichever never changes will obviously confuse me, to say if it's that IP address, really it's a failed DNS resolution. Another thing is that in the API, you can tell it to wait for a number of seconds before timing out. So if you want to be able to poll rather than just block on a read, waiting for a message, you can tell it to wait. And my convention is to say wait for and then the number of the units you're using. So you don't say wait. I think is that floating point seconds? Is it whole seconds? Is it days? So I put wait for. Now, what I originally had was wait, W-A-I-T, underscore for, F-O-R, underscore S-C-C-S, wait for seconds, right? Now, imagine reading that out loud in a dojo or classroom situation, okay? So I then abbreviated that to wait for S, which kind of works. Or if it were milliseconds, I'll put MS or whatever. But these are the kind of things you realise when you're sort of doing that. And then really getting the UDP, the discovery beacon working, which generally works quite well actually, that's got a lot of robustness in there, that's where the network differences between sockets really shows. Because sockets tries to be a layer, sockets in general, and the Python sockets module tries to be a layer on top of these things, but the number of difference between them is, substantial. And it's obviously why modules like NetInterfaces and NetZero Q may have that place. Okay, I'm going to leave it there. I do have time for a couple of questions if anybody wants to give any. Otherwise, thank you very much.
Thank you, Tim. Do we have any questions at all? Yeah, John, second one.
I had never heard of the Zero library ecosystem before this talk. If you had an unlimited amount of time to work on anything, what's another Zero library you think?
I suppose that's a talk for somebody else, really, but a question for somebody else in a sense. There are things like, the thing I would like most to see is inputs, which Zeph Technical Zeph, who's at the conference here, has started working on, has done some work on, things like keyboard input, mouse input, trying to simplify that, because that's something which can help, particularly in the dojo or classroom situation, and would actually help me in this. But that's somewhere where I think it might be worth looking, but obviously you can pick up anything you like, scratch one's own itch, and that kind of thing.
Any more questions? I have a brief one. Why, I assume there's a really good reason for this, having heard about it in the past. Why do you not use something like Bonjour or something like that?
Okay, so I do have, in fact, if you look on the online docs for this, there's a series of design decisions, sort of questions, why don't use that. Ultimately, Bonjour, as far as I could see at the time, wasn't particularly stable cross-platform, and you need a little bit more infrastructure support to make it work. So my intention was this will work on, well, I was going to say core Python, in fact, with my extra modules, so not quite, but the intention is you can install it and run it on its own. Bonjour needs a little bit of service support and so forth. But it's definitely a thing, and I think I've said in the design docs, if somebody said, well, actually, you could do this by replacing this and this, I would be open to doing that.
Okay.
Yeah, cool.
Okay. Thanks very much then.